At its core, Katana does three things: ingest data, process and modify data, and export the final data to a render engine to process. Templates are the preferred way of setting up your pipeline of ingest, modification, and export. Let's break down the pipeline in a lighting context a bit more. Let me just resize this so you can see this better. Alt plus middle mouse is to zoom in and out, by the way, and with middle mouse you can pan around in the node graph. The first step is to load models, textures, shaders, and look files. This part will be different in every company depending on their asset pipeline and integration into Katana. The Importomatic is a centralized supernode where you load your assets. Under the hood, it uses the individual nodes like Alembic in, look file assign, or XML assign nodes to load the necessary data. We will be using this node later to set up our shots in a way where we can switch to different shots with ease. In the setup section, we then define our root, our base attributes for our templates. We can do this either using a root look file and load it via the look file manager, or like in this case, we just set up the attributes directly in the current template. In general, look files are baked templates of attributes and most commonly used in LookDev to bake out the shader and attributes for an asset to be used in shot. You can see the attributes set on root by selecting the root in the scene graph and looking at the attributes. A root look file is a recipe of attributes we need to set globally on the root, like resolution, AOVs, and render settings. The globals node here on the side sets certain variables we want to be available throughout the template, for example the base path of our project and version numbers for our renders. The material section, as its name says, is where we load any materials, for example the chrome and grayscale shader. Shader assignments are also done here. I generally split my setups into sequence and shot setups. By defining settings and lights which are common on the sequence level before doing any shot overrides allows us to create a base setup to quickly run a multitude of shots without having to create a light rig per shot. From the sequence setup, we go into the shot work, where we can adjust and alter each shot individually. In the render settings and pre-pass adjustment sections, we define render globals, AOVs, and quality settings, which are depending on the light rigs and shot content. These can be global settings, but usually are settings which don't make sense to set at the start of the template. Passes defines the render outputs and how to split up the rendered elements. To be able to switch to different shots and output renders per shot, we will leverage scene graph variables, which is a very powerful tool built into Katana to define context-based variables. Switches and groups will allow you to change your upstream node graph based on these context-based variables. Let me show you the Project Settings tab. Here you can see the variables I have already set up in this example. Once we start creating our own templates, you will be setting these up as well. We need to change a few preferences before we start building our templates. Go to Edit and Preferences. A new window will pop up where you can change Katana's preferences. Go to Application, and in Application you have a variable called Interactive Render Thread 3D. This variable controls how many CPUs you use when you render an image interactively in Katana. Rendering taxes your system quite a bit, so you want to set it up to always have one CPU free in your system. We can render multiple interactive renders at once as well. I try to not run more than 2 interactive renders at the same time, and my system has 32 cores. So dividing that number by 2 and minusing out 1 core, I set my interactive 3D render threads to 15. With this number set, I can set off 2 interactive renders which will use 30 cores and I have still 2 cores free for system interactivity. Interactive Threads 2D is for the compositing nodes within Katana, but since we won't be really using these, we can leave this at the default setting. If you're working with a 4K monitor like me, take a look at the font size. The default of 11 can be very small, and I have to increase mine to 18 to help with readability. Now switch to 3D Light, and here set Progressive Refinement to on. Progressive Refinement basically tells the renderer to start with a very low resolution render and iteratively increase the quality instead of rendering bucket by bucket. Render time overall will go up a bit, but you will see the initial results faster, which is a very useful thing when setting up light rigs. Lastly, switch render view from both to Katana. 3D Light has its own render monitor, but for now, to make things easier, we just want to use Katana's own built-in monitor. Hit OK and we are set.